Now, we can still do a rejection regions, but then we have to remember with rejection regions, what do you have to find? You have to find your critical values of the rejection region. Well, that's where this table, this last table that we're going to use, table A6, finds the, notice in small print, critical values for R. And it creates a rejection region. Notice, it's very specific though. It only can use one of two alphas. Either you have an alpha of 0.05 or 0.01. And you have to know the size of your sample. And there's only a couple choices. We've only got 4 to 20. And then we go up in units of 5s and then 10s. So there aren't many choices. But this will give us our critical values, which will make up our rejection region. So let's go ahead and use our Lin-Reg t-test and the critical values to determine if we think that there's a linear correlation. We're going to just redo the last problem that we just did. So we'll look at the same exact problem with the size and revenue involving casinos. So we've still got the size is still going to be our X's, our list 1 in our calculator. We'll still have our Y's as our revenue. That will be our list 2 in our calculator. And we still also have our alpha of 0.05 to actually go ahead and test and make up our critical values to make up our rejection region. So you would start off the same way we did this before with the P's and alphas. You'd start off by putting in list 1, doing your stat, your edit, and plugging in all your X's for the size of the casinos first in list 1. And then in list 2, you'd plug in all your revenues, your Y's. You would go hit your stat button again, go over to test and hit your Lin-Reg t-test, which is way down in the list. Except for last time we used the P. This time we would arrow down and we'd use the R. This is going to be our test statistic. And remember, your test statistic is what we need to determine whether or not it falls in the rejection region. So we use an R of 0.44. This is our test statistic, and we need to figure out if that falls in within our critical values to determine our rejection region. So how do we find our critical values for our rejection region? Well, we need to use our table. So let's figure out what our critical values are for our rejection region. Well, first of all, we need our alpha. Our alpha for this one was 0.05. Now, what was our N? Well, remember, N is the size of the sample. Well, if you go back to our original problem, we had 1, 2, 3, 4, 5, 6, 7 sizes and 7 revenues 7 numbers that we put it as our X's and our Y's. So that's what our N is, 7. So what this means is if we look at where the 7 and the alpha of 0.05 overlap, we get the value of 0.754. So that's what's going to create up our picture for our rejection region. How rejection regions are going to work for these R values is it's going to look something like this. Look like -1 and 1 is here. Here's our 0. Then we'll put our values that we just got from our table. I know that we just got 0.754 on our table, but we're actually getting 2 values. We always take the positive version and the negative version. So the negative version will go down here as negative 0.754, and the positive version will go on the other end as positive 0.754. Okay, how does this help me? Well, anything that's going to fall inside from where my critical value is to the high end of 1, or anything that falls in between -1 to where my critical value is, those are going to be considered grouped in with 1. that's when you have a correlation. So you'll have a correlation if you're at those ends. However, if you're grouped in the middle of those two critical values, and that means you're going to be grouped in with the 0 that's in the middle. What does 0 mean? That would mean no correlation. So anything that lands in the middle, though, is going to be considered no correlation because you're landing inside with the 0 instead of the 1s. Here's a better picture on the next page. Again, we had our critical values, which were at the negative 0.745 and the positive 7.45. We had anything that falls in the middle with 0 is going to be considered no correlation. Anything that falls in on the ends with the 1 and the negative 1 would be considered that there is a correlation. So the only question you should be answering is, what was your test statistic and where does it fall? Well, go back to your Lin-Reg-T test. What R did it spit out? Well, it spit out an R test statistic of 0.44. Where is that on our picture? Our R of 0.44, our test statistic, is landing in the middle. It's landing in with the 0. Well, if it's landing inside with the 0, that means that we're going to end up saying that there isn't a correlation. So what does that let us do? This is where we reject. We're going to reject the claim that there is a linear correlation. So we're going to say that there is insufficient evidence to say that there is a linear correlation. We couldn't say that there's a correlation, so we're going to say there's not enough evidence to do that, to say that there's a correlation, because we're falling inside the middle, where we're saying that there is no correlation. So we're just going to say there's not enough evidence to say there's a correlation, and we are. So how does this really line up with hypothesis testing? In Chapter 10, we're always going to be claiming that there is a linear relationship, a linear correlation. And that is part of what's going on. We're claiming that there is a linear correlation. So our H naught is going to be the reverse, that there's not a linear correlation. And so we're going to always be looking as to whether or not we're failing to accept or whether or not we are accepting the claim. We're either failing to accept or we are accepting it. We're either saying, if we fail to accept, we're saying there's insufficient evidence. We're failing to accept, that's when we say are insufficient evidence. Evidence. If we accept, though, we're going to say we're doing something then, that there is sufficient evidence. And there is sufficient evidence. Of what? A linear correlation. So those are really our two options that we're looking for here, and that is it. And that's about as in-depth as we're going to get into it. But we do a p-values approach, and we do the rejection region. It's just if you use the rejection region, you have to use the A6 table to come up with, it's kind of like a two-tailed rejection region.